Hi guys, our project was on the 2019 Missouri River flooding by Anna, Elizabeth, and Gabriella. So to give some background on why the Missouri River led to such severe floodings was because throughout the winter months, Missouri saw extremely cold temperatures and a lot of rain and snowfall. Due to the constant rain or snow, the ground and soil stayed constantly saturated and therefore was frozen all the time, making it difficult for the water to infiltrate into the soil. As you can see in both Table 2 and Table 3, Table 2 showing the average rainfall for different counties in Missouri, where average or Table 2 showing the average snowfall, and the largest or the greatest amount of rainfall was 6.84 inches, and the most snow was 20 inches. So moving forward into March of 2019, a severe winter storm hit Missouri, which led to mass snowfall and rainfall. However, due to rapid northward movement of warm air, the snow melted really fast. And with that, the melting snow and a lot of rain that was still happening, there was a lot of excess water that was minimally infiltrated into the ground due to the soil being still saturated and frozen over. So there wasn't enough, like, water couldn't absorb into the ground. This led to tons of water continuously flowing into local streams and rivers. However, those were also frozen, so the water was breaking up the ice and making massive ice jams and eventually led to a terrible flood, which left a lot of Missouri flooded. So the Missouri floods, a lot happened that broke, like their dams and levees broke, which happened due to the storm and the amount of water that was being pushed into them. An example of this was the Spencer Dam, which broke an 11-foot wall of water and it made the water go downstream into a city in Missouri. Another example is a levee that was breached by water, which led to 30,000 of 95,000 acres of Holt County to flood. The image of the dam shows Spencer's Dam after the flood subsided and it's completely broken. And the other image gives an example of how the damage was done and how significant the flooding was.
So regarding the magnitude and frequency of the Missouri flooding, floodwater spread over many states, including Nebraska, Iowa, Missouri, Kansas, and South Dakota, with several areas experiencing record-breaking water levels. And also, the extreme flooding persisted for weeks, and many areas had elevated water levels into the following summer of 2019. And here are two pictures of the Missouri River in 2018 and then after the flooding in 2019. So the frequency and magnitude of the flooding of the Missouri River Basin was amplified by both climate and anthropogenic factors. Gabriella kind of touched on the climate factors of how the Missouri River Basin was dealing with an extreme wet period, which caused very overwhelming runoff. But some anthropogenic factors included the management and infrastructure of the rivers, including the levees and dams were breached because of the overwhelming runoff that occurred. The agricultural practices reduce the land's ability to absorb water, and also similar to agricultural practices, the urban development, the increase in impermeable surfaces also cause the land's ability to absorb water to go down.
So the societal and economic factors were the flooding caused of roughly $11.6 billion in damages, and 1 million acres of farmland were flooded and ruined. There were 42 wastewater plants that had failed during the flooding, which resulted in a lot of untreated sewage being spewed into towns and land nearby. In Nebraska, there were 6 water system plants that failed, which meant residents were asked to cut down their water consumption by half, and private wells were at risk for contamination of bacteria and chemicals. Another effect from the flooding was that Interstate 29 was closed for several months, almost a year, and when it opened again, flooding was still very bad on the roads. And then here is a satellite image from before the floods. The green, red, and blue are crops, water, and like buildings. And then this is after the flooding, which is the blue is the water, obviously, and then um, you can see the difference of how much the flooding resulted or affected the surrounding areas.
So after the flood, a main priority was to fix the damaged flood control devices across the Missouri River. So the flood flooded over 100 levees, which was a main cause to a lot of the infrastructure damages. And rather than just fixing the current one, they decided to build one that was set back, moving it backwards to allow for the river to be bigger. There were multiple benefits to this, and some ranging from being better for the fish and wildlife to also being better with for the water quality for human life around it. The new levee was built in 2020 and completed in 2021 and brought optimism to the future and flood control aspect. Another flood control device that was sparked after the 2019 flood was the use of trap bags, which were a newer and better version of sandbags. Trap bags offered a leak-proof protection to dams, seawalls, levees, and other types of flood control devices, and they were better than sandbags because they didn't require ground infiltration. The trap bags lined the walls, as you can see in that second image, and they were hopeful that this would help in the future in different floods.
Many rules and regulations were put into place after the Missouri flooding, which some examples of this would be strict floodplain regulations, which involved understanding the flood risk for future development, and also elevation requirements, which was buildings in flood-prone areas would have to be above base flood elevation. Also, levee advancements, which included raising, relining, straightening to damage levees to avoid the overwhelming runoff that was such a big factor into the Missouri flooding. And lastly, changes in agricultural land use. They now use strategies like cover crops and no-till farming techniques just to let the land be able to absorb more water to avoid the overwhelming runoff that occurred during the Missouri flooding. And these are our sources. Thank you.